സോ ലാസ്റ്റ് ഡിസ്കസ് ചെയ്ത ന്യൂമറിക്കൽ ചെയ്ത് നോക്കിയിരുന്നോ? ഹലോ ഹലോ
സാർ
ലാസ്റ്റ് ഡേ തന്ന ന്യൂമറിക്കൽ ചെയ്ത് നോക്കിയിരുന്നോ?
ഇല്ല സാർ.
അതെന്താ? അത് ചെയ്ത് നോക്കിയില്ലെങ്കിൽ ആ ന്യൂമറിക്കൽ പോയി കേട്ടാ. ഇനി അതിനെപ്പറ്റി വേറെ സംസാരിച്ചിട്ട് കാര്യമില്ല. ഇത് ഒരുപാട് കഷ്ടപ്പെട്ടിട്ടല്ലേ ഞാൻ ക്ലാസ് എടുക്കുന്നത്. എന്താ നിങ്ങൾ ചെയ്തു നോക്കാഞ്ഞ്? ആരും എന്താ ചെയ്തു നോക്കാഞ്ഞ്? ഹലോ എന്തിനാ ക്ലാസ് ഒക്കെ വെറുതെ റെക്കോർഡ് ചെയ്യുന്നത്? എല്ലാ വീഡിയോയും യൂട്യൂബിൽ ഇട്ടിട്ടുമുണ്ട്. Okay, next topic is principle of virtual work. See, principle of virtual work is basically another methodology through which we can do the static force analysis. Till now, we have been doing the static force analysis with respect to a 4-bar mechanism or a slider crank mechanism with the help of drawing the free body diagrams. So, one method of obtaining the static force analysis and finding out the torques for balancing the or keeping the system in static equilibrium was drawing the free body diagram. So free body diagram method was one method that we have been adopting till now. And another method which we can use for doing the static force analysis replacing the free body diagram method is known as principle of virtual work. So fundamentally this concept is applied as a methodology to do the static force analysis. That's all. That is what you have to remember. Suppose you are having a slider crank mechanism and on the link number 4 there is an external force F acting on the system. Now due to this action of the force F, the whole system will be getting displaced by certain value. Okay, let me mark the imaginary displacement like this. Let the total displacement of the system be like this. Now, the displacement in exact terms occurring to the piston or the slider, let that be denoted by delta x. Let the displacement happening to the piston in particular be denoted by delta x. Now, when you take the crank, the displacement happening will be in angular motion. That means if this angle is theta, the change in angle, that means this particular value, let that particular value be taken as delta t theta. So due to the action of an external applied force F, the piston is being displaced by delta x distance, and the crank is having an angular displacement of delta theta. Now, see, the principle of virtual work can be stated as the work done during a virtual displacement from the equilibrium position of a system is considered to be equal to zero. See, virtual work means imaginary work. So principle of imaginary work is that it should be stating that the work done is zero, then only the work is said to be imaginary. So the work done during a virtual displacement of a system from equilibrium is always equal to zero. Work done during a virtual displacement, that means an imaginary displacement. So if you think there is an imaginary displacement occurring, then we can consider that the work done during that imaginary displacement is said to be virtual work, or work is actually zero. That means the virtual displacement may be defined as an imaginary infinitesimally small displacement of the system. See, when you consider the displacement occurring within the given system to be very, very small, that much small that we can simply ignore the displacement. If the displacement is that much small, or for that we use the term infinitesimally small, then we can consider that displacement to be a virtual displacement, imaginary displacement. That means if a system is undergoing such kind of displacement, that is a virtual displacement, then the work done for that particular virtual displacement should be zero. Now, by applying this principle, an entire mechanism can be examined as a whole. That means we don't have to divide the system into free body diagrams anymore. We can apply this principle to the system as a whole. Now, see, look at the example that I have drawn. You have a slider crank mechanism on which a piston force F is acting. Now, due to this action of piston force F, definitely an external crankshaft torque should be acting in this direction in order to keep the system in equilibrium. Now, if you ignore friction, okay, friction is ignored, and then you look at the different parts of the system carefully, apart from the applied force F, comma, the applied torque or the torque which is generated, which is acting externally on the crank or link number 2, there is a force at the bearings. That means you have bearings at positions O, A, and B. They are all link connections. O is the connection of link number 2 with the fixed platform. A is the connection between link 2 and 3, and B is the connection between link 3 and 4. So definitely these connections are made due by installing bearings. So you have bearings at positions O, A, and B. Definitely when the system is moving or having a displacement, that displacement will come in effect at the points of these bearings also. So apart from the external applied force F and the torque which is generated on link number 2, you have bearing forces or reactions at O, A and B. Now, the bearing reaction at O will not perform any work because O is basically a fixed position. So definitely there shouldn't be any bearing forces. There shouldn't be any work generated by the bearing forces because it is not being detached from the fixed position. That means reaction of the bearings at O or bearing reaction at O performs no work. Now, when you look at bearing forces at A and B, you can say that AB is a C. A and B, if you take the free, if you just look at the free body diagram of AB, if there are two forces acting at A and B, that means as the system is considered to be in equilibrium, both the forces at A and B should be equal and opposite. We have learned it from the free body diagram method. That means if you have bearing reactions at points A and B, they should be equal and opposite because AB is a two force member. Hence, the bearing reactions at A and B also does not do any work. That means due to the bearing reactions or force at the bearings at positions O, A and B, no work is done. Okay, that means definitely the force F which is acting on the piston does work, and the torque generated at the second link would also do the work. But you ignore the friction, so don't have to consider the work spent for overcoming friction. Then the bearings which are at O, A and B, as we have explained, they are also affected by the force, but the reactions generated at the bearings does not produce any work. Now, when you look at the piston alone, as the piston is sliding, now if you consider this to be an IC engine, the piston will be definitely sliding inside a cylinder. So definitely there will be a force on the cylinder and that force will be projected onto the piston. The reaction forces from the cylinder will be acted upon on the piston. But these reaction forces will be acting perpendicular to the piston displacement. See, piston is being displaced in a translational direction like this. But if you consider this to be a cylinder, if there is a cylinder like this, the forces from the cylinder onto the piston will be acting like this. Those piston forces direction will be perpendicular to the piston movement because the piston movement is like this and the piston forces, cylinder forces acting on piston will be perpendicular to that. So if the forces are acting perpendicular to the motion of the object, there is zero work done because work is force into displacement. So if F and S both are in perpendicular direction, the work done should be equal to zero. That is also clear. Hence, the two forces or external, a torque and force that is doing or generating work within the system are only F and T. All the bearing reactions at O, A and B does not do any work. Then the forces generated by the cylinder onto the piston when the piston is sliding, that also is not doing any work. I hope this is clear. So only the events that happen that generate work are the external force F being acting and the external torque T being acting. Hence, for the same system, we can consider that work generated for this system will be only due to F and T. And that also, if you look at the external torque T, then the work done by the torque T will be equal to T multiplied by delta theta. Now, the work done by the force acting at piston, which is F, and the work done due to that force will be F into delta X. So, work done by the torque is T delta theta, Work done by the force F is F delta x. Now, we have generally assumed from the smaller classes itself, you know that we usually take the work done to be positive if the force is acting in the direction of displacement. So if the force is acting in the direction of displacement, that means when the force F is acting, sorry, when the force F is acting in this direction on the piston is displaced to this direction only. That means this work done will be positive. Now, what about this side when the torque is acting? Now, basically, the displacement that is happening to the link number 2 is in the anti-clockwise direction. Hence, the applied torque should be in the clockwise direction so that it stays in static equilibrium. That means the work generated here is negative. So, ultimately, we can say that the work generated by the force F is positive, but the torque generated uh, by T at link number 2 can be taken as, or the work done due to the torque is taken as negative. Hence, according to the principle of virtual work, if you consider this total displacement delta x and delta theta to be infinitesimally small, they are considered as virtual displacements. Hence, in the case of virtual displacement, the total work done should be zero. That means the total work done here, which is the total work done is T delta theta equal to F delta x. Right, because one is negative and the other is positive. That means the total work done should be T delta theta plus F delta x should be equal to 0. This is the total work done. Now, even though the displacement is said to be infinitesimally small, if there is a displacement happening, that displacement should be happening over a time interval, some time interval, because the displacement cannot be instantaneous displacement. So if you consider delta t to be the time interval over which the displacement is occurring, that means the displacement is happening, displacement delta x and delta theta is happening over a time interval of delta t, then we can write this equation number 1. Now, what is equation number 1? T delta theta plus F delta x equal to 0. How did you obtain that? We know the total work done for this system is minus T delta theta equal to F delta x. So, work done is 0 if the displacement is infinitesimally small or virtual displacement. That is the principle of virtual work. Now, applying principle of virtual work, we arrive at equation number 1. Now, the total work done or displacement, even though they are virtual, is occurring or considered to be occurring over a time interval of delta t. Hence, if you apply this time interval to this equation number 2, we can write it as t into d delta theta will become delta theta over time interval t, that is d theta by dt, plus this will become dx by dt, because they are the delta x and delta theta are occurring over a time interval of delta t. So this can be taken as 0. Now you know that time dependent change in theta is nothing but omega. Rate of change of angular displacement, delta theta is angular displacement. So rate of change of angular displacement is nothing but omega, angular velocity, plus rate of change of delta x, which is linear displacement, is nothing but linear velocity. This is 0. So this equation becomes t into omega plus f into v equal to 0. And since usually for force analysis problems, we are actually calculating the torque, which is the final answer for the usual static force analysis problems, we can write an equation for T as F into V by omega. So this is the equation that we obtain by applying the principle of virtual work. This is the equation that we will be using for solving static force analysis questions using principle of virtual work. Is this concept clear? I hope this concept is clear, because asking you several times will not change anything. You will simply say that all the concepts are clear and you won't do the work that is being told to do in the class. So there is no use in asking if this concept is clear or not. I'll be simply wasting my time. Because basically what I have understood is you people don't have any interest in listening to the class or learning what is being told in the class. So now what I'll do is I'll simply oblige by my duty of taking or completing the syllabus. Somehow or the other I will complete the syllabus. ഈ ക്ലാസ് കേട്ട് പുച്ഛിക്കുന്നവർക്ക് പുച്ഛിക്കാം, ചിരി വരുന്നവർക്ക് ചിരിക്കാം. ബിക്കോസ് ഐ ക്യാൻ എക്സാക്ട്ലി ഇമാജിൻ ഓൾ യുവർ ഫേസസ്. നിങ്ങളെ ക്ലാസ്സിൽ ഞാൻ കണ്ടുകൊണ്ടിരിക്കുന്നുണ്ട്. ഓരോ ആൾക്കാരുടെ മുഖം എങ്ങനെയായിരിക്കും എന്ന് എനിക്ക് ഇമാജിൻ ചെയ്യാം. എസ്പെഷ്യലി ഇപ്പോൾ വീട്ടിലാണ്, നമ്മൾ പരസ്പരം കാണുന്നുമില്ല. Anyhow, so this is the principle that we can apply for doing the static force analysis questions. Okay, now how to numerically apply this principle of virtual work. Now consider a slider crank mechanism. Okay, I simply shown two forces acting on this mechanism. The one force is FB, which is acting at the slider in the direction shown in the figure. And the other force is FE, which is acting at point E on the connecting rod. And that is also acting in the direction which is shown. Now, what you're supposed to do is you're supposed to calculate the torque T2, which is basically acting on link number 2 due to the action of these two external forces, so that the whole system remains in static equilibrium condition. This is the question you are supposed to answer, and you are specifically instructed to use principle of virtual work. Use virtual work principle. How you will be doing this question. Now, last class what we have done or discussed is question similar to the same given condition. You are given a standard tank mechanism on which two sets of forces are acting. So we have drawn the free body diagrams for each uh, links, and we have ultimately arrived at the answer or calculated the torque which is required. See, during the discussion, the difference of that question was there was no link in the system which is a two force member. Each link number 2, 3, and 4 were having three forces. Link number 2 was a two force and a torque member. Link number 3 and 4 were three force members. Hence, what we considered was we took the free body of link number 2, and at the point B, we considered the force. There is a force F43. We considered there to be two components of the force. One is acting normal, F43 normal, along the link, and the other was F43 tangential, which is acting perpendicular to the link. And here it was, the point was A. Now you have the had the force Q. I remember. I hope it was denoted as force Q at some point G or something. It was given. Now we calculated, use taking the moment about the point A. We calculated it like this. You have the perpendicular distance x here. So it was, when you calculate the moment about point A, the equation was q into x plus f for 3t into length AB equal to 0. This was the equation that we obtained. Now from this one we obtained the direction and value of f for 3t. Then we simply took the opposite counter values for f34t and f34n. Then we drew the free body diagram of the fourth link. There were four forces now, and we drew a force polygon, and we found out the value, magnitude, and direction of the other forces. And like that, we have completed the question. Now, that was the method opted by drawing the free body diagrams. Now, in this question, you are supposed to apply the which one? You are supposed to apply principle of virtual work. Now, let that be free body diagram or principle of virtual work for any matter. First method is to draw the configuration diagram. So, initially you have to draw the configuration diagram. That is a mandatory step. Now, you all know how to draw the configuration diagram. Now, apart from this data, in the question there are few other values also given. Those values will be the values of the lengths. That is, let O2A be given as 100 mm, AB is given as 250 mm, AE is given as 50 mm, angle AO2B be equal to 30 degree. Now let the force FB acting on the piston be equal to 2000 Newton. Let the force Fe acting at the point E on the connecting rod, let that be equal to 6000 Newton. These are the data given. ഇതൊക്കെ കാണാൻ പറ്റുന്നുണ്ടാവും വിചാരിക്കുന്നു. ഓക്കെ, താല്പര്യമുള്ളവർക്ക് ഇത് നോട്ട് ചെയ്തെടുക്കാം, അല്ലെങ്കിൽ സ്ക്രീൻഷോട്ട് എടുക്കുക, എന്താണെന്ന് വെച്ചാൽ ചെയ്യാം. നിങ്ങൾ എന്തായാലും ചെയ്തു നോക്കാമെന്ന് പോകുന്നില്ല. ചെയ്തു നോക്കിയാൽ നിങ്ങൾക്ക് കൊള്ളാം. നിങ്ങൾ അൾട്ടിമേറ്റ്ലി യൂണിവേഴ്സിറ്റി എക്സാം ആണ് എഴുതേണ്ടത്. ഞാൻ തരുന്ന സീരീസ് എക്സാം ഒക്കെ അതിന്റെ പാർട്ട് മാത്രമാണ്. യൂണിവേഴ്സിറ്റി എക്സാമിനേഷൻ ഇങ്ങനത്തെ ക്വസ്റ്റ്യൻ വന്നാൽ നിങ്ങൾ എന്താ ചെയ്യേണ്ടത് നിങ്ങൾ തീരുമാനിക്കുക. അതിനനുസരിച്ച് നിങ്ങൾ പഠിക്കോ പഠിക്കാതിരിക്കോ ചെയ്യാം. This is basically the question that is given. So basically the first step is to draw the configuration diagram. Okay, so for drawing the configuration diagram, you have to take the corresponding scale, convenience scale, and draw it according to your convenience. Now here what we are going to do is we are going to apply the principle of virtual work, not the method of free body diagrams. Hence we won't be drawing any free bodies. Now from the principle of virtual work we already know that we are supposed to find out the torque T2. So for finding out the torque, we have the equation F multiplied by linear velocity v divided by angular velocity omega. Now F denotes to the forces which are having effect on the system. That means forces which contribute to the work done. Now in the previous example that we have taken during the explanation of principle of virtual work, we had only one force which was acting on the piston. Now there is definitely a work done due to this force. All the other forces like bearing reactions or the forces due to the cylinder on the piston all were existing but they were not doing any work. So now the forces that contribute to the total work done will be in this particular question it will be one will be FB and the other will be FE. These two forces will be acting which will be contributing to the total work. So we can simply, if this was the general equation, we can modify that general equation with respect to this question as T2. We are finding out the torque T2 here should be equal to, simply elaborate. Okay, there was a negative sign in this one. ആ നെഗറ്റീവ് സൈൻ ഞാൻ കഴിഞ്ഞ ഇക്വേഷനിൽ എഴുതിയോന്ന് എനിക്ക് ഓർമ്മയില്ല. നിങ്ങൾ ആരും നോട്ട് ചെയ്തിട്ടുണ്ടാവില്ല, താല്പര്യമില്ലല്ലോ ആയിരിക്കും. ആ ഇക്വേഷൻ നമുക്ക് കിട്ടുന്ന ഇങ്ങനെയായിരുന്നു, ടി ഇൻറ്റു ഒമേഗ പ്ലസ് എഫ് ഇൻറ്റു വി ഈക്വൽ ടു 0 എന്നായിരുന്നു കിട്ടുന്നത്. So T should be equal to minus F into V by omega. This was the equation. ആ മൈനസ് അവിടെ എഴുതിയിട്ടുണ്ടോ എന്ന് എനിക്ക് ഓർമ്മയില്ല കഴിഞ്ഞ ഇക്വേഷനിൽ. എനിവേ മൈനസ് ഉണ്ട് ഇവിടെ. സോ മൈനസ് എഴുതിയോന്ന് എനിക്ക് ഓർമ്മയില്ല. സോ മൈനസ് ഉണ്ട്. So T is equal to, the general equation was minus F into V by omega. Now when we apply this principle to the particular question that is given here, we can modify this equation as T2 is equal to, in place of F we have to now substitute all the forces that are doing work here. Now all the forces that are doing work in this particular question are only FB and FE. So correspondingly we can simply change this equation as, in place of F I have to now write down FB as well as FE. Correspondingly the value of linear velocities will also change according to the force. That means I can write, since Fe is greater in value 6000 Newton, I am writing that particular term first, minus Fe into corresponding Ve, minus of, in place of the other F I'll write Fb and multiplied by the corresponding velocity, linear velocity value Vb, whole divided by angular velocity is simply one value, because the link number 2 is the link where torque T2 is acting and the angular velocity is corresponding to that link. So we have only one omega value. This is how we write the equation of principle of virtual work for this particular question. Now we have two forces Fe and Fb acting here, hence we have these two terms in the numerator. If there are more number of forces like this acting on the other link sources, suppose there is an additional force acting on the link number 2 also, then we will have one more term in the numerator. That is how we modulate the equation.